Okay, good day. This is dual enrollment pre-calculus. I am Mr. McCulley, and this is lesson number 6, synthetic and long division of polynomials with real zeros. Let's get right to it. Today we're going to talk about long division, divide polynomials by other polynomials. We're going to use synthetic division to divide polynomials by polynomials of the form x minus a, or linear polynomials. And we are going to use remainder theorem and the factor theorem. We're also going to talk about the rational root test to determine the possible rational zeros of polynomial functions. And then we are going to determine the upper and lower bounds for zeros of a polynomial function. So real quick, polynomial function has the form where f of x equals a sub n x to the n with all of these possible terms. And again, we've seen that before. N has to be a whole number. And so we're talking about division today. So let's real quickly go way back to 3rd grade when you learned some long division. And let's just do a simple one. Let's do 3 divided by 10. Now, if I say 3 divided by 10, 3 goes into 10 3 times. 3 times 10 is 9, and then 9 gives you a 1. And so right here we have the divisor, the dividend, and the quotient, and the remainder. And from this, we can say that 10 is equal to 3 times 3 plus 1. And so 3 times 3 plus 1 gives us the original 10. And that's going to be important because we're going to be essentially doing this once again, except we're instead of using whole numbers, we're going to use polynomials. So the division algorithm. The division algorithm says this: if f of x and d of x are polynomials such that d of x does not equal 0, and the degree of d of x is less than or equal to the degree of f of x, then there exists unique polynomials q of x and r of x such that this division algorithm holds true, where r of x equals 0 or the degree of r of x is less than the degree of d of x. If the remainder r of x equals 0, then we can say that d evenly divides f of x. So what does all of that mean? Well, notice we have something similar here. We have an original value. We're multiplying two values together plus some remainder. So we can think of that as this part here, where this thing is f of x. This right here is our d of x. This is our q of x. And this is our r of x. All right, and so we're going to do that with polynomials. Okay, let's go down to this next one, maybe. The rational zero test. You'll remember this from Algebra 2 last year as the P over Q test. So if you have some polynomial, and here we have another example of the polynomial that we saw on an earlier slide, has integer coefficients. Now remember, integers don't have a ton of time, but integers are your counting numbers plus your negatives. So an integer does not have a decimal, it's not a fraction, it's not a square root of a prime number. Every rational zero, now a rational number, we think of rational numbers by thinking of the first 5 letters, the ratio, and so a rational number is any number that can be written as a fraction. So it has the form P over Q, so that's a fractional value. So again, integer coefficients, that means that these numbers, this a sub n and every a sub n1, a sub n, a sub 2, a sub 1 and a sub 0, those are all integers, counting numbers with your negatives, and then rational zeros are fractional zeros. So the top number has to divide the constant, which is a sub 0 right here. That's where I get that. And this q value divides a sub n, which is that value right there. And I will show an example of that here very shortly. Consequences of synthetic division substitution. If f of x is a polynomial, and for some constant c, f of c equals 0, then we can say x minus c is a factor of f of x. And so this C value, when you go x minus that number, we get a factor, and we'll see examples of this. And the converse is also true. If f of x is a polynomial and for some constant c, f of x equals 0, then we can also say that x minus c divides f of x. And when I say divides, that means divides evenly. So just to kind of go back here, we could say that 3 does not divide 10 because we had a remainder. But we can say that 3 divides 12 because 3 into 12 is 4 times with no remainder. So we can say that. Descartes' rule of sign, let f of x be a polynomial function. And we see another one where we have real coefficients and that last term is not 0. The number of positive real zeros, so the number of positive numbers that could possibly give you 0 when you plugged it in, is either equal to the number of variations in sign of f of x or less than that number by an even integer. So as for instance, if you have 3 changes of sign, then you could have 3 positive zeros or 1 positive 0. The number of negative real zeros of f is equal to the number of variations of sign in f of negative x. So this means that you have to plug in negative x first, or less than that by a number negative number, or start again, or less than that number by an even number. So if you get, say, 5 changes of sign for that one, you could have 5, you could have 3, you could have 1, and we'll see examples of that here also very shortly. Upper and lower bounds, let f of x be a polynomial function with real coefficients, and those real numbers could be fractions, decimals, anything. And a positive leading coefficient, then suppose f of x is divided by some x minus c by using synthetic division. If c is greater than 0 and each number in the last row is either positive or 0, then c is an upper bound of f, and that means that there is no value c in that list of p over q that we'll find that you should even try, because this c value is the biggest possible one, and all of those would also be upper bounds. If c is less than 0, then each number in the last row is alternately positive and negative. 0 counts as either positive or negative in this one. Then c is a lower bound, and again, we're just saying that you can discount anything that would be less than that value for c. And I'll show an example for that. Actually, we're getting to examples right now. A long division example. I did a long division of numerical values earlier on, but let's just make up one here real quick. Let's say that we are going to divide x minus 2, you know what, let's make it x squared minus 2x plus 3, and let's divide that into, so we won't go real crazy here, x to the third minus 2x squared plus x minus 1, and we'll do that division. And so what we want to do is the only values that we're going to look at here when we're considering how to do this division is we're going to consider the first term of each of these two. So I look at this and I say to myself, what times x squared is x to the third? Well, that's fairly simple. X times x squared is x to the third. So since I'm multiplying by x, I'm going to put my x there, and I'm going to keep it, since it's x to the first, I'm going to keep my x to the first column lined up, and you'll see in a couple of examples out of the book where that's going to be beneficial. X times x squared is x to the third. X times negative 2x is negative 2x squared. X times 3 is 3x. And then we'll pull this down here. Got a parenthesis, we do a subtraction. X to the third minus x to the third is 0. Negative 2x squared times minus negatives like plus positive, so I got negative 2x squared plus 2x squared. That also gives me 0. And then x minus 3x will give me negative 2x and then minus 1. And so right here, since, oops, come on, the degree of the remainder is less than the degree of the divisor of the, yeah, we are finished. And so my final answer is going to be x plus the remainder, negative 2x minus 1, all over the divisor, x squared minus 2x plus 3. There we go. Okay, so here we have our synthetic division example, and a couple things that we want to talk about first. First, get the right tool here. You can only use synthetic division with a linear divisor. So because this is x to the first plus a constant, this divisor is linear, and so we can use synthetic division. Also, we wanted to note that the x squared term is missing, and so we need a placeholder. So we need to use 0 as a placeholder. So here's what I want to do. I want to write the coefficients of the dividend. And so here is my dividend. And so I'm going to write 5. And then I need the 0 for the x squared. I need the 6 for the linear term. I need the 8 for the constant term. All right, actually, let's maybe spread these out just a little bit more. Try it one more time. 5, the 0, the 6, and then the 8. All right, then we're going to draw our line. I'm going to put a box here, and in the box, place the value that makes the divisor 0. So here's my divisor, x plus 2, and I ask myself, what plus 2 is equal to 0? Well, negative 2 is what makes that equal to 0. And so we go through and we do our synthetic substitution. We bring that first number down, so we bring the 5 down, and then we multiply up. So negative 2 times 5 is negative 10. 0 and negative 10 is negative 10. Negative 10 times negative 2 is positive 20. 6 and 20 is 26. 26 times negative 2. Okay, so negative 2 times 6 is 12. Negative 2 times 20 is 40. 40 and 12 is 52, and it's negative because negative times a positive is a negative. And then when I add these together, I get negative 44. All right, so we're done, and we need to get to our final answer. And so we started with x to the third, and so we need to know this is 5x to the what power? Well, we just did, so let's note here. Let's see if I can do this better. Note that we just did x to the third over x. At some point, we did 5x to the third divided by x to the first. So 5x to the third divided by x to the first is going to be 5x squared. So whenever you divide here, remember, we're canceling out that 1. 3 divided by, or excuse me, x to the third over x to the first is 3 minus 1 gives me the 2. So this will be squared. And then we go minus 10x, and then it'll be plus 26. And then since it's negative 44, if we can go minus 44 over the divisor, x plus 2, and that is going to be our final answer for this particular problem. All right, next one. This is from the text. It is on page 125, number 40, and they give you a polynomial function and a value for k, and I pick a value that shows that we can still do synthetic division with an irrational number. So we want to write this thing in the form f of x equals d of x times q of x plus whatever the remainder of r is, and then we're going to use a graphic calculator to show that f of whatever k is, in this case negative square root of 5, is equal to r. All right, so we need to do the division, and so I want to do this division. I'm going to use synthetic division. All right, so I'm going to write my coefficients of, let's see, what is it, f of x. And so I've got a 1, I've got a 2, I've got a negative 5, I've got a 4. Notice I'm not missing any, so I didn't need any zeros in this case. And in this case, the factor, all right, so this, the factor would be x plus square root of 5. So we're just going to actually use this negative square root of 5 here. So I bring down my 1. 1 times negative square root of 5 is negative square root of 5. Now here's the deal. 2 times negative square 2 plus negative square root of 5 is 2 minus square root of 5. And then when I multiply negative square root of 5 to these two terms, I have to distribute. So and we can multiply in any order. So negative square root of 5 times negative square root of 5. Negative times a negative is positive. Square root of 5 times square root of 5 is 5. And then negative square root of 5 times 2 would be negative 2 square root of 5. So when I add these two together, the negative 5 and the positive 5 cancel out. I got negative 2 square root of 5. And then when I multiply this, negative square root of 5 times negative square root of 5 gives me 5. Times 2 would be 10, and so negative 4 and 10 is 6. And so for part A, and again, we started with x to the third, we divided by just x, so this will start off x squared, and then it will be plus, here is my coefficient, and even though it's not just a whole number, we can still use that as a coefficient, 2 minus the square root of 5, and that will be x. And then it will be, this will be our constant, so minus 2 square root of 5, and then we have a remainder of 6, so let's just, of 6, and I'm doing this a little, I want to erase this, and I apologize. I need to write it in f of x equals this form. So f of x equals, okay, my divisor is going to be this thing right here, so x plus square root of 5, and then it is going to be, here's my coefficient, so x squared plus 2 minus 5x, and then minus 2 square root of 5, that's my constant. So here is my d of x, this is my q of x, and I made a little bit of a mistake, and I'm sure that you're screaming right now at me that this should be 2 minus square root of 5, not just 2 minus 5, so there's my square root of 5, and then plus my r of x, which is 6. And then part B says use a graphing calculator to show that f of k is equal to r. Well, that's not too hard. Just got to type this in here real quick. Let's see here. Let's quit out of this. Let's clear everything out. And so I need to do, oops, I didn't want to do that. Sorry. I just need to be able to type here. We're plugging in square root of 5, so I need parenthesis, plugging in negative square root of 5. So negative second square root 5, and I don't want that there, so delete, parenthesis raised to the third, and then plus 2 times second, oops, I don't need a second yet, at negative second square root of 5, square that, and then minus 5 second, I don't want to do second yet, a negative square root 5, and then minus 4, and I need to check to make sure because we can't see. I think I want to put a multiplication symbol here in between here, and we can do that. Use your D-pad here, and we can do second insert and put a multiply there. That way we get minus 5 times. We should get that. Hopefully we get 6 out, and we did not. What did I make? Where did my mistake happen here? Plus 2. Oh, there's my problem. I need a. Sorry. Let's bring that back up. It's squaring this 5 first, and then it makes it negative. I need to put a parenthesis. I need to have a closed parenthesis right there. There we go. There, I got 6. And so the mistake was I didn't have that parenthesis there, so it was squaring a negative. And so it squared, gave me 5, then made it negative, then negative times 2, and that was my problem. So we have that. Let's see here, a couple more examples here. Given this function here, x equals x to the third minus 31x plus 30 equal to 0, and x equals negative 6, use synthetic division to show that the given value for x is a 0, and then use the result to find the remaining zeros. Okay, so first thing I want to write the coefficients, and use, remember, 0 for missing coefficient, or for missing terms, let's say that. S-I-N-G, terms, T-E-R-M-S. Okay, so I've got 1 for the x to the third, I've got a 0 for the x squared, I've got negative 31 for the x, and I have 30, and then we want to show that this thing is a 0, okay? So since this is a 0, we're using that value right there. So I bring down my 1, 1 times negative 6 is negative 6, I add 0, I get negative 6, negative 6 times negative 6 is positive 36, plus the negative 31 leaves me with 5, 5 times negative 6 is negative 30, that gives me a 0, and now since I have 0 there, x plus 6 divides x to the third minus 31x plus 30, and x equals negative 6 is a 0. All right, so what we have left is x squared minus 6x plus 5. Now it wants us to find the remaining zeros, so we have a couple options. We can factor, or we can use the quadratic formula. Now I look at this thing and I say 2 factors of positive 5 that equal negative 6. Negative 1 and negative 5 work. So I'm going to go like this and say x minus 5, x minus 1, and then x times x is x squared, x times negative 1 is negative 1x, x times negative 5 is negative 5x, plus the negative 1 gives me negative 6, and then negative 5 times negative 1 is positive 5. So those are the factors. And so the remaining zeros would be x equals 5 and 1, what makes this thing 0 and that thing equal to 0. Okay, next one. it says given this function right here and x plus 3, it says verify that the given factor of the functions. And so I'm going to, again, I'm going to write my coefficients. This one does not have any missing, so I won't have any zeros. So I've got my 3, I've got my 2, I've got my negative 19, and I've got 6. And so I make this negative because this is a factor, not a 0. And so we're looking to put the 0 here. So negative 3, bring down my 3. 3 times negative 3 is negative 9, plus 2 would be negative 7. 7 times negative 3 is 21. That'll give me 2. 2 times negative 3 is negative 6, giving me a 0. So this would be 3x squared minus 7x plus 2. And again, we could try and factor or the quadratic formula. And since my leading coefficient isn't 0, I'm going to use the quadratic formula. And since we didn't do it on the last one, I think I could possibly factor this one, but I haven't done the quadratic formula. So let's try that. So I'm going to say x is equal to negative b, so 7 plus or minus the square root of negative 7 squared minus 4 times 3 times 2 all over 2 times 3, so 2a. And then I get x equals 7 plus or minus, let's see here, negative 7 squared. Negative 7 times negative 7 is 49. 4 times 3 is 12, times 2 would be 24, all over 6. And then this should be, I made a mistake here, sorry about that. This should be a minus. And so I get 7 plus or minus the square root of 25 all over 6. Square root of 25 is 5. 7 plus or minus 5 over 6. 7 plus 5 is 12. 12 divided by 6 is 2. 7 minus 5 is 2. 2 over 6 is 1/3. And so those are the remaining zeros. All right, so let's see here. It says verify that the given factor, we've done that. That's part A right there. And so part B says write the remaining factors. B, remaining factors would be, these are the zeros, remember. So x minus 2 and x minus 1/3, those are the remaining factors. C asks us to write the complete factorization. So we have x minus 2, x minus 1/3, and then x, let's see here, plus 3, because remember, x plus 3 is a factor, and that's equal to f of x. I wrote that a little bit backwards, but you get the gist. And was there a D? Make a list of all the zeros. We've already done that. Negative 3, 2, and 1/3. That's my list of zeros. So there we go. Use Descartes' rule of sign to determine the possible zeros, real, negative real zeros. And so if we want to look at f of x, it's negative 3x to the third plus 20x squared minus 36x plus 16, sorry. And so for part A, positive real zeros. I go from, starts negative, so it changes to positive. There's one change. To negative is 2 changes. To positive is 3 changes. So I have, it should be real zero, sorry about that, 3 changes in sign, right? So I could have 3 or 1 possible positive real zeros. Now, to find the possible negative real zeros, I have to first plug in negative x. So I've got negative 3 times negative x to the third plus 20 times negative x squared minus 36 times negative x plus 16. Okay, so when I do that, Negative times itself 3 times gives me a negative. Times a negative 3 will give me 3x to the third. Negative times a negative is positive, so I get x squared. And so x squared times 20 would be positive 20x squared. Negative 36 times negative x is positive 36x, and then plus 16. So here I have 0 changes in sign. All right, and since I have 0 changes in sign, there are 0 possible negative real zeros. All right. It says use, let's list all the possible rational zeros. So I need to do a P over Q here. And so part B, my p-value is all of the values. I'm going to use my highlighter here. All of the possible divisors of 16. And so I've got plus or minus 1, plus or minus 2, plus or minus 3. Oh, nope, 3 does not divide 16. Sorry. That was almost bad. 4 plus or minus 8, and plus or minus 16. And then my values for Q, and I'm going to use a highlighter again. Let's use that light blue because that's easy to see. I'm looking for the divisors of negative 3. And so plus or minus 1 divides 3, and plus or minus 3 divides negative 3. And so my list of P over Q is the list of all possible combinations of this list as numerators and the Q list as denominators. So I got 1 over 1, 2 over 1, 4 over 1, 8 over 1, 16 over 1. That's just going to be those values again. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Just some commas in here. Plus or minus 16, and then 3 doesn't divide any of those, so I also have to do it for 3. So plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, plus or minus 8/3, and then plus or minus 16/3. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible, times 2, actually 20 possible rational zeros. Since it's a third degree polynomial, we could only have 3 zeros. So here's what we're going to do. We're going to use the graphing calculator. We're going to go to the y equals. We're going to clear out what we had there. We're going to type in this polynomial again. So 3x to the third plus 20x squared. 3x raised to the third plus 20x squared. And then, let's see, plus 36x plus, oops, that's not right. That's not the original, that's that minus. So I need a negative and then a negative there. So let's get this right. Second, insert a negative. And then it was minus 36x, and I think plus 16. Let's take a look here. Yep, we're good. And so let's hit graph, see what we got. And so we only have positive values. It looks like possibly right here, that's 1, 2, 3, 4. So let's see, what does it ask us to do? Use graphing utility to reduce the zeros and then verify all of the real zeros. So we did that. So for part D, I'm going to write my coefficients of my original. So negative 3, it was then positive 20, negative 36, and then positive 16. I need to check. Yep. And so I think, what did I say here? 4. 1, 2, 3, 4 is a possible zero. Yep. So I'm going to put a 4 there. Got negative 3. Negative 3 times 4 is negative 12. And then I bring down, I'll have an 8. 8 times 4 is 32. It'll give me a negative 4. 4 times negative 4 is negative 16, giving me a 0. And so I'm going to use, so this would be 3x squared plus 8x minus 4. I'm going to use the quadratic formula on it to find the remaining zeros. So I got x equals, it'll be negative 8 plus or minus the square root of 8 squared minus 4 times negative 3 times negative 4 all over 2 times negative 3. That'll be negative 8 plus or minus the square root of 64. And let's see here, 4 times 4 would be 16, and then 16 times 3, 15 times 3 would be 45 plus, so 3 negatives gives me a negative, I think it would be 48 all over negative 6. And then let's see here, 64 minus 48 is 16, so that'll be 4. Negative 8 plus or minus 4 all over 6. So my remaining zeros, negative 8 plus 4 is negative 4 divided by 6. I get negative 4 over 6 is going to be negative 2/3. And then negative 8 minus 4 would be negative 12 divided by 6 would be negative 2. Although, oh yeah, negative 2 or positive 2 right there. Just a simple mistake here. This should be, I forgot to bring down the negative, so I get a negative divided by a negative is going to give me a positive on both of those instances. So those are my remaining zeros. All right, last one. Says, given that f of x is that thing, show that x equals 4 as an upper bound, and that's going to be a possible 0, and we know that it's a possible 0 because it divides 8. Negative 3 is not a possible rational 0, but we can still show that it's a lower bound, a value that we wouldn't check. And so I'm going to start with the coefficients of f, and so I've got 2, I've got negative 3, negative 12, and then 8. And so I'm going to put this 4 right here. So 2, bring down the 2. Go 2 times 4 is 8. Bring down 8 and negative 3 is 5. 5 times 4 is 20. 20 and negative 12 is 8. 8 times 4 is 32 is 40. Notice all values are positive. And since they're positive, since every single one is positive, we know 4 is, or x equals 4 is an upper bound. And then we need to do the same thing, 2, negative 3, negative 12, 8, except this time we're going to do it with negative 3. And so I bring down my 2. 2 times negative 3 is negative 6. Plus 3 is negative 9. Negative 9 times 3 would be positive 27. 27 and negative 12 is positive 15. And since 15 times negative 3 would be negative 45, negative 48 is going to be, oh, we need to dismiss that. Sorry about that, folks. Negative 37. Yeah, we'll go with that. All right, so this should be note. So again, note the signs alternate positive, negative. Thus, x equals negative 3 is a lower bound. All right, I know that's a lot, folks. I tried to make it as quick as I could and as painless as I could. That is all review stuff. We had it in Honors Algebra 2 last year. Again, if you have any questions, you can ask me in class. But we're on to the Star Wars fun fact of the day. Back in 1977, when they finished or they wrapped doing episode 4 in Tunisia, they just left all of the set remains, and it is still there to this day. In fact, a new form of tourism has sprung up around these, I guess we'll call them artifacts. They're only 40 years old, but They still seem they are in decay. So this tourism fans make a pilgrimage to Tunisia to see what's left of that Star Wars site. Well, that's a pretty long one, folks, and I apologize for that, but that's all I got. See you in class. Bye.